Good morning, this is your stats sensei, Mr. Spensei, and we're going to be working on a pre-quiz for two sample proportions. And this is going to be a hypothesis test. And I'm just going to let you know the scenario is it's just weed. Tumbleweed, commonly found in the western United States, is a dried structure of certain plants that are blown by the wind. Cochea is a type of plant that turns into tumbleweed at the end of the summer and is a problem for farmers because it takes nutrients away from the soil that would otherwise go to more beneficial plants. Scientists are concerned that cochea plants' resistance to the common herbicide glyphosate has changed over time. There were millions of cochea plants treated with glyphosate in 2014. That's a lot, millions. And in 2017. In 2014, 12 out of 63 randomly selected, oh, we have a random sample, were resistant to glyphosate. In 2017, 21 of 57 randomly selected cochea plants were resistant to glyphosate. All right. At an alpha equal 0.05, has the weed become more resistant? You know what? I'm going to go ahead and write that alpha level down because we know what it is. So we know our alpha level is 0.05. All right. So our hypothesis. Well, the hypothesis is the proportion hasn't changed. So HO P1 equals P2. And HA P1 being 2014 is less than P2 because in 27 if this is 2014 and this is 2017, we're saying this group is more resistant than this one. So 2014 is less resistant than 2017, or 2017 is more resistant than that. All right, I'm going to go ahead and fill out our important information, and I'm going to call this as 2014, and I'm going to call this 2017. And we have 12 out of 63 in 2014. So this is going to be 1263. And in 2017, it's 21 of 57. So this is 21 and this is 57. So if I have that information, I might as well go ahead and do my P hat 1 and P hat 2. So P hat 1 is going to be 12 over 63. 12 over 63. And 12 divided by 63 is about 19%. So 0.1904. And P hat 2 is 21 divided by 57, which is about 36%. So 0.3684. All right, let's go ahead and do our parameters. So let P1 equal the true population proportion of cochea that were resistant in 2014. P2 is going to be the same thing. Let P2 equal the true population proportion of cochea that were resistant in 2017. Our formula for P hat C, because we're going to need that in order to do our conditions. Please note it's P hat C that we're looking for. So P hat C equals X1 plus X2 over N1 plus N2. So P hat C equals 12 plus 21, 12 plus 21 from there, and 63 plus 57. So this is going to be 12 plus 21 is 33. 12 plus 21, 33. And then 63 plus 57 equals 120. So P hat C is 33 divided by 120, which is 0.275. All right. So our conditions, and by the way, this is 2014's conditions, and this is 2017's conditions. One, we have a random sample. So random sample of 63, and that's given. Here is a random sample of 57, and that's given. Two independent samples given. It really makes sense that 2014 shouldn't impact 2017 and vice versa, because this is a random sample. We have to do the n is less than 10%. So in this case, n equals 63. 63 times 10 equals 630. And that's less than, and they said, what was our population size? When I look back, they said they treated millions. So less than millions. 630 is definitely less than millions. Over here, same thing, but our sample size instead of 63 is 57. So n is 57. 57 times 10 is 570, which is also less than millions. That's good because that means we can sample without replacement. All right, these conditions here, 1 through 3, are exactly the same. They didn't change at all from the confidence interval. But number 4, the normality condition is different, because on the confidence interval is N1 P hat 1 and N2 P hat 2. But here we have to use P hat C. So N1 P hat C and then N1 times 1 minus P hat C. Over here it's going to be N2 times P hat C and N2 times 1 minus P hat C. So N1, my sample size is 63. So 63 times, well, what was P hat C? 0.275. And this is going to be 63 times 1 minus 0.275. So let's calculate those out. 63 times 0.275. 17 is approximately 17. That's greater than 10. We're good to go. I don't mind the rounding as long as we're greater than 10. 63 parenthesis 1 minus 0.275. And we get 40, almost 46. It's approximately 46. And that's greater than or equal to 10, so we're good to go. Over here, our sample size is 52. So we're going to go 52 times 0.275 and 52 times 1 minus 0.275. Again, it's the same P hat C as we have on both sides. Now, this number is going to end up smaller because it's a smaller sample size. So 52 times 0.275 is 14. And that's greater than or equal to 10. Not much bigger than 10, but it's big enough. As long as it's bigger than 10, we're good to go. And then we're going to go 52 parentheses 1 minus 0.275, close those parentheses, and we get 37, almost 38, and 38 is greater than or equal to 10. So we're good to go there. We have enough. Our formula, Z equals P hat 1 minus P hat 2 over P hat C times 1 minus P hat C over N1 plus P hat C times 1 minus P hat C over N2. All right, so I need to plug in. So we want the probability that Z, and when I look at this, it's a less than. So this time we're working with a less than. Probability that Z is less than. I'll make this pretty long. Well, P hat 1 is 0.1904 minus P hat 2 is 0.3684. All right. Now I need to drop in P hat C, which is 0.275. So 0.275. Let's go ahead and figure out what 1 minus 0.275 is. 1 minus 0.275 is 0.725. And that's going to be over my sample size, which here was 63, plus 0.275 times 0.725 all over 57. All right, let's calculate. Let's run this thing. Stat, test. Drop down to number 6, 2 proportions, z-test. And we have a sample, we had a 12 that were resistant in 2014 out of 63 versus 21 that were resistant in out of 57 in 2017. Then when I look at my alternative, we said, oh, we needed a less than. And we calculate, and I end up with a negative 2.180. So I want the probability that Z is less than negative 2.1800. And that's approximately 0.0146. Well, 146 is less than 500. So I'm going to reject the null. All right, so we rejected that hoe. All right, when we'll take a look at this real quickly. There's my p-value. That first number is my p-value. There's my p hat 1, 0.1904. There's my p hat 2, 0.3684. And there's that 0.275, which is my p hat c. All right, and we can also scroll down and see our sample sizes of 63 and 57. So we need to go ahead and write our conclusion. All right. And we start off just the way we have been. Our p-value is. So our p-value is 0.0146. What was our decision? We reject the null. Why? Because there is sufficient, in other words, we have enough, we have plenty, sufficient evidence at alpha equal 0.05 to suggest that the true population proportion of resistant cochea plants is, how did we do this? Less than 20 in 2014 than in 2017. True proportion of cochea plants in 2014 is, our alternative was less than, is less than in 2017. So basically, we're saying The proportion of resistant cochlear plants measured in 2014 is less than that in 2017. And it's statistically significant. We believe that there is a change. All right. I appreciate you watching. I hope to see you on the next one, and I sure hope this helped. Thank you.